Okay, in part 2, we're going to look at the formula on the right side of this formula sheet. And as we look at number 9, we see that instead of being a typical equation, this is an inequality. So it's in the form of slope-intercept over here. But instead of having just an equal sign, there's an inequality sign right there. So this is red. Y is greater or equal to 2x plus 1. Now, the same holds true. This is in slope-intercept. So what is in this B position here? The positive one, that's the y-intercept. And what's in the slope position, that is the numerical coefficient of x, that is your slope. And remember we said slope is a ratio of rise over run. So these would be y units compared to x units. And this leads to something I could have gone over here, but I didn't want to make that too long. A special way of graphing when an equation is in slope-intercept form, as we see here. Rule number 1, plot the y-intercept. That is where it will cross the y-axis right there. And it's a positive 2 over 1 for the slope. So the rule is you go over 1 up 2, and that's your second point. So right here, this portion of the line and the whole line has the slope of 2 over 1. That is, it's going to go over 1 unit for run and up 2. And when you make these on MATLAB, because it's not only greater than or equal to, well, greater than, but also equal to, you're going to make this line solid. It means that all of the points in this line, plus all of this region above the line, are solutions to this inequality. And in MATLAB, there's a bucket of paint that you pour, and I think that's kind of fun. You pour it right over there and it fills it out. Okay? But this line is solid. Why? Because it's greater than or equal to. And then I have here over on the side, anytime that a positive y is greater than something, you are going to shade above the line, like I have illustrated here. So again, solid line, shade above. All right, for this one, it's y is less than, not equal to, just less than 3x plus 2. So, again, you're going to put a dot on your y-intercept, which is 2. The slope is 3 over 1. So I'm going to go over to the right 1 unit. I'm going to go up 3. There's my second dot. And then here's a little difference from above, that since y is less, the part that you're going to shade, as I have indicated here, is below the line. So that's the part you throw the bucket of paint. Okay? And since it's only an inequality and there's no equal sign, the line that you choose in MATLAB will be dotted. Okay? Now as we look below here a little bit, we see some other hints that I had mentioned in the previous part of this tape. The x and y intercepts, that if you put a 0 there and a 0 there. Solve for this. That will be the y-intercept, and this will be the x-intercept. And I think maybe this is a good time to actually do a little example of this. So let's make a line here. New graph. There's a graph here. Okay. And let's write an equation. Let's say 4x. Let's see if I can get my pen working again. Plus 5y equals 20. Now you might recall that's in standard form. Whenever it's in standard form, that was equation 1, this is a good one to use. So if x is 0, that x is going to be 0. This will be both sides divided by 5. B will be 4. And my ordered pair here will be 0, 4. This, by the way, is the official way to write the y-intercept. And then now if y is 0, that y is a 0, 5 times 0 is 0. So we have 4x equals 20. Divide both sides by 4, we get x equals 5. And then so this will be a 5. Now when I graph that, my 0, 4 is going to be here. 1, 2, 3, 4. A dot right there. And this is going to be a 5, 0. 1, 2, 3, 4, 5. A dot right there. And I get my line. And there it is right there. Okay, now notice there's your y-intercept at 0, 4, and there's your x-intercept at 5, 0. So again, you're going to have lots of practice on your homework, and then later using it on your quiz me, and then later the test. But here are some little hints as to where this reference sheet comes in. Okay, and then this is more toward the end of the chapter, where we're talking about the domain in terms of function, relation, domain, and range. Domain, by definition, in an ordered pair, refer to the x elements. Range in a set of ordered pairs refer to the y elements. And you'll be putting that into your practice examples and your quiz me's. Now a function, by definition, is if the x element in a series of ordered pairs is only used once every time. It's only used once. So if you have a -1 and a 2, and a 2 and a -3, and a 4 and a -5, you have a 2, 3, 4. Those are different. So that would be a function. And let me just write for you an example of one that wouldn't be. So if you had something like this, 1, 2, 1, 3, and then 2, 4. You see the 1's are used more than once? So this would not be a function. But if this, I changed it to a 4 now, I'd have a 1, a 4, and a 2. The x's are not repeated. The x elements only used once in each ordered pair. Then that is a function. And we also have, I didn't put this on here, but I can add it, something that's called the vertical line test. The vertical line test is having a super thin imaginary line that you're going to move over your diagram. Now, as this imaginary blue line moves over the diagram, does it intersect my graph in more than one place at a time? Imagine it. And the answer is no. So this, we say, passes the vertical line test. And this positive slope example is a function. Now, if you had another one that looked like this, circle, and again, you're passing that vertical line over that circle, well, it would intersect there and it would intersect there as it went over. So it intersects it more than one place as you move it across the face of the diagram. This is not a function. Some other ones you might run into is a sideward parabola. Well, that would be an open parabola to the top or bottom. This does pass the vertical line test, and this line has to just go off that way a little bit, while a sideward parabola would not. So this one here is a function, this one is not. The last few things is some terminology, set builder notation. If this is your relationship here, which is an inequality, to put it in what we call set builder notation, you would just use braces, add an X, vertical line, and write it like this. This is red. X is such that X is greater or equal to 6. Now, putting this in interval notation, you would say that it's going to start at 6, as we see in this graph here, and we put that in a bracket indicating that 6 is a member of that set. And then where does it go to? Well, it goes to positive infinity, and that's how you would write interval notation for that. And that's the graph. Actually, I like to have the students do the graph first, because from the graph it goes right into interval notation. And this is just another one where X is less than 6. Again, set builder notation, interval notation, and then the graph. Notice it's coming from negative infinity here, going up to 6. 6 is not a member of the set, and we use a parenthesis for that. If that were equal to, then we would have used a bracket. Okay, just some stuff. You're going to pick up a lot. Try to give a little general review and keep it somewhat short. And good luck with you on this.